Hello guys, welcome to my YouTube channel. In this video we're gonna learn about some special types of integrals. So here we're gonna discuss about the gamma function and beta function. So let's start with the gamma function. So what is a gamma function? It is a special type of integration. Suppose it is an integration which is from 0 to infinite, then it is an improper integral, and this value is equal to gamma of n. So whatever this type of integration comes, we can just compare the value of n from the coefficient, from x, and find the value accordingly. Okay, so this symbol denotes the gamma function, and the value of this gamma of n we have to calculate. Okay, so then what exactly is the value of n here? Now here this n is positive real numbers. Okay, that is, now how to find this type of integrations using the value of gamma we will see now. Before that, let's find out how to calculate this gamma function. So we will start with n as positive integers. Okay, so what are the integers then? Integer set of integers is denoted as z. Okay, and which is defined as all the positive and negative numbers of this form. Okay, and this is a infinite numbers. Now from here I am taking n as only positive integers, so I am just taking these values. Okay, and another thing here is that this n value is not 0. Okay, as for the definition here you may note that this gamma function is not defined for 0 and negative integers, and for some negative numbers we can actually find the values. We will see that in later section, that which type of negative numbers we can find. So now let's start. Suppose what is the value of gamma n? Here that the first formula comes, so it is gamma of n equal to n minus 1 factorial. Okay, so this is the first formula. Now how to use this one? First we will understand what is this n minus 1 factorial. So if there is a number n, then the factorial of n would be defined as n into, then subtract 1 from here, it would be n minus 1, then again subtract 1 from here and multiply with the previous term, then again subtract 1, it would be n minus 3, and so on subtracting. After certain points we will get 3, 2, 1. To see this, suppose let us take an example. What will be 5 factorial? So we will start this from the number n. Okay, so the first number is 5, then we will reduce 1, it would be 5 minus 1, that is 4, then again we will reduce 1, it would be 4 minus 1, that is 3, then again reduce 1, then it would be 2, then again reduce 1, it would be 2 minus 1, that is 1. So now what is this value? This is 5 into 4, 20, into 3, 60, into 2, 120. Okay, in this way we can find this one. Similarly, suppose if I am taking 4 factorial, then it would start from 4, So the first number is 4, then reduce 1 from 4, it would be 3, then again reduce 1, it would be 2, then again reduce 1, it would be 1. So now this value is 4 into 3 into 2 into 1, that is 12 into 2, 24. Okay, so next we will see another formula on basis of this n minus 1 factorial. Okay, so that is gamma of n is equal to n minus 1 gamma n minus 1. So this thing also works as the same rule, but this is used for a broader purpose. Suppose if we are not given exactly integers, suppose we are given positive fractions, okay, then in such cases we will use this formula. Okay, so now let's see some examples where we have to find this gamma value using this formula. Okay, so it is used if suppose I will ask you how to find gamma of 5.4. Now see, this is not an integer value, okay, as this is a decimal value, so in this we have to use this formula. Okay, so here what is the value of n? Here n is 5.4, so the next value would be 5.4 minus 1 into gamma of 5.4 minus 1. So that is, now here this value is 4.4 and this value is gamma 4.4. So see, again this 4.4 is not an integer value, so we have to use the same formula as like this. So here now the n value is 4.4, so using this formula we will get this as 4.4 minus 1 into gamma 4.4 minus 1. So see, now again here this value becomes 3.4 into this value is gamma 2.4. Now see, again this is a decimal number, so again we have to use the first formula to find this gamma 2.4. So I'm writing directly, now this value would be 2.4 into gamma 1.4. Now see, this value is gamma 1.4. So whenever in positive numbers the value lies between 1 to 2, we won't go for the solving. Okay, instead we will use the numerical value available in the calculator. Okay, so you can use this value in the calculator and find what is this gamma 1.4 and find the answer. Okay, so next we will move on to another type of numbers, which is suppose I want to find gamma 9 by 2. Then here also we will use the same formula as above, which is gamma of n equal to n minus 1 gamma n minus 1. So let's use this rule. Okay, so see, what is the value of n here? Here the value of n is 9 by 2, so the next number would be 9 by 2 minus 1 into gamma 9 by 2 minus 1. Okay, so in this way this would be 7 by 2 into gamma of 7 by 2. So then again to calculate gamma 7 by 2 we will use the same formula, and here the n value would be 7 by 2. So for this gamma of 7 by 2 we can find the value as from this function, which is n minus 1 into gamma n minus 1. So now see, this value becomes, it is 7 by 2, this is 5 by 2, and this is gamma of 5 by 2. So continue in this process, we will find this gamma of 5 by 2 as 3 by 2 into gamma 3 by 2. Then again this gamma 3 by 2 would be half into gamma half. So here also we won't go beyond this value, which is gamma half, which is a standard value, which is root pi. Okay, so we stop here, and the answer would be, you can multiply and find this one. Okay, so it is 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2, and this value is root pi. The gamma values for negative non-integral values. So what are these values? So one thing I want to confirm, that we cannot find the values of gamma function for negative numbers, that is negative integers particularly. Okay, which is if n is -1, -2, -3 and so on, we cannot find the gamma. Okay, but for negative non-integral values we can find. Okay, so what is that non-integral values? So these values are, suppose like -5.7, -4.4, etc. Okay, so to find gamma values for such numbers, we will use the formula, which is gamma n plus 1, which is equal to n gamma n. And how do we find out this formula? It comes from the elementary formula, where it was gamma of n, which is n minus 1, gamma n minus 1. So here if I add 1 here, then 1 will be added here also, and it will be added here also. So see, this part became n plus 1, and here this n is substituted to n plus 1, and there is 1 minus 1 here, so plus 1 minus 1 would be cancelled out. Then here also, in place of n, it would be n plus 1. Now this plus 1 and minus 1 would be cancelled out, so this value is n. So this value became gamma n plus 1 equal to n gamma n. So now let's find out the value of -5.7 using this formula. So it is gamma of -5.7. So this value would be, we are using this formula, right? Here the n plus 1 value, it is n gamma n, so we will use modification of this formula. Okay, so what we will use here, now suppose I will take this n to the left hand side, then this value would be gamma n, which is equal to gamma n plus 1 by n, right? From here, at place of n, I will think the given value. Okay, so this is the formula to find this negative non-integral values. Okay, so this is the second formula. The first one is the elementary formula, that is, either you may think this one or this one, both are equivalent. Okay, this is the first formula. Okay, so this first formula was used to find numbers. Like here it was, this formula, first formula, used for n value, which is integers which are positive. Okay, then we also find out numbers like 9 by 2, 5 by 2. Okay, and in the second formula we will find the values of gamma function of this type. Okay, so let's start. So first value is gamma -5.7. So here n value is -5.7, so in the right hand side it would be -5.7 plus 1 by -5.7. so see, now this value is gamma minus 4.7 by minus 5.7. So again, see, this is again a non-positive, that is, it is a negative non-integral value. So again, I can use this formula to find out this one. Okay, so now let's find out this gamma minus 4.7. This value is gamma minus 4.7 plus 1 by minus 4.7. Okay, so instead of n, I'm using these values. Okay, so now this value would be gamma minus 3.7 by minus 4.7. So see, again, this is a negative non-integral value, so I will use the same formula to find this value. It would be gamma minus 3.7 plus 1 by n, right? It is minus 3.7. So now this value is gamma minus 2.7 by minus 3.7. So again, for this gamma minus 2.7, I can use the same formula. So it would be gamma minus 2.7 plus 1 by this. Now this is gamma minus 1.7 by minus 2.7. So again, this is a non-integral value and it is negative. So this value is minus 1.7. It would be gamma minus 1.7 plus this value is 1 by minus 1.7. So this value is minus 0.7 by minus 1.7. So again, we will use the same formula. It would be gamma minus 0.7, so which is equal to gamma minus 0.7 plus 1 by minus 0.7. So now this value became 0.3 by minus 0.7. So now the value of gamma 0.3 can be obtained from the table values, or you can also use the calculator to find this one. Okay, so if the n value is from 0 to 2, then you can use that calculator. Okay, so now how to find out this value? Then just resubstitute all those values. Okay, so first is gamma minus 5.7. This is gamma of minus 4.7. So this gamma of minus 4.7 is again gamma of minus 3.7 by minus 4.7. So let's write what will be this value. So now this value is gamma minus 5.7, which was equal to gamma minus 4.7 by minus 5.7. So it is the first line. Okay, so this is the first line. So again, from here I have find out the gamma 4.7 minus 4.7, which is gamma of minus 3.7 by this much. So for this I am writing gamma of minus 3.7 by minus 4.7 divided by minus 5.7. So now see, this value will be changed to gamma of minus 3.7 by minus 5.7 into minus 4.7. So again, substitute the values for gamma of minus 3.7. So what is the value of gamma of minus 3.7? It is gamma minus 2.7 by this much. So this is gamma minus 2.7 by minus 3.7 divided by minus 5.7 into minus 4.7. So see, this is in the numerator part, so this minus 3.7 will come down to the denominator. So it would be gamma of minus 2.7 by minus 5.7 into 4.7 into minus 3.7. And if you go on continuing in this step, so we will find out that this value is, now see, what is gamma minus 2.7? It would be gamma minus 1.7 by minus 4.7 minus 3.7 minus 2.7. So again, what is gamma of minus 1.7? It is gamma of minus 0.7 by minus 5.7, 4.7, 3.7, 2.7, 1.7. So again, the value of gamma 0.7, it would be gamma of 0.3 by minus 5.7 minus 4.7 minus 3.7 minus 2.7 minus 1.7 into minus 0.7. So now see how much negative numbers are there. It is 1 minus, how many minus are there? 1, 2, 3, 4, 5, 6. So there are 6 minus. So after multiplying, these are all will be positive. Okay, so we just use the calculator to solve this expression and find out the answer. So now you are able to find the, so now you know how to find the values of gamma function. So we'll see some exam questions how it is coming. Suppose in exam it is given that to find, suppose it is given that find e to the power minus x to the power 10 dx. Then if you remember the formula, then see, this is a gamma function, as the gamma function is from 0 to infinite e to the power minus x to the power n minus 1 dx. So now just compare what is the value of this n minus 1. So just see clearly this n minus 1 is 10, right? So what is this value? This value is after gamma of n, right? So from here find out the value of n. So what is the value of n? N value is, take this one to the right hand side, it would be 10 plus 1, that is 11. So the right hand side value n is 11. So the answer would be gamma of 11. Okay, so it is a short question. Similarly, suppose if it is in the form of this, suppose x to the power 5 dx, then also you can compare that here the n minus 1 value is 5. Okay, comparing with this equation, so the value of n is, take this one to the right hand side, it would be 5 plus 1, that is 6. So this value would be equal to gamma 6, and you know how to find this one. It is gamma of n. Okay, so it would be n minus 1 factorial, that is 6 minus 1 factorial, that is 5 factorial. Okay, so now let's move on to some transformations of this gamma function. So these transformations are other form of this gamma function. Okay, so now we will see those transformations. So to see the transformations, so first we will write what are those function first. So let's see now. Suppose first I'm writing the function. It is gamma of n, which is equal to 0 to infinite e to the power minus x into x to the power n minus 1 dx. So now let's substitute this x with lambda y. Then how to substitute? We are changing this function from x to y. Okay, so first we will change this dx, then we will change this limiting values. Okay, so how to find dx? Now differentiate both sides with respect to x, then this one would be, it is dx by dx, and this value would be d of lambda y by dx. So now the left hand side is 1 and the right hand side, see here the lambda is a constant. Okay, or it is a real number. Okay, so as lambda is a constant, it will go outside of the derivative, and this part would be lambda into dy by dx. Now take this dx to the left hand side, it would be dx equal to lambda dy. Now the dx part is over. Now I have to change this limit of integration also. So take the lower limit. So when x is equal to 0, then value of y would be put in this equation. Okay, as x is 0, so this value would be y is equal to x by lambda. So it is 0 by lambda, which is 0. Similarly, the upper limit, when x is infinite, y would be x by lambda, that is infinite by lambda, which is infinite. So the upper limits and lower limits for y are infinite to 0. Okay, so now let's change the integration. Okay, so now this integration would be, see, this gamma n equal to limits of y. Okay, here the limits of y will come. So y's limits are from 0 to infinite. Then next term, it is e to the power minus x, and at place of x we have taken lambda y, so it would be e to the power minus lambda y into x. What is the value of x? X is lambda y, so it is lambda y to the power n minus 1 into dx, right? Here there is a term dx. So what is the value of dx? Dx is lambda dy, right? So now resolve this thing. It is 0 to infinite, it is minus lambda y. Now see, this is a bracket and the function is to the power n minus 1. So if I want to take this lambda outside of this bracket, then it will go with the power. Okay, so it would be lambda n minus 1 into y to the power n minus 1 into lambda dy. Okay, so now see this value, this is lambda to the power n minus 1, this is lambda. So here the base is lambda and here also the base is 1. And what is the power here? Here the power is 1. So when base are same, then after product the power will add up. Okay, so this one is lambda to the power n minus 1 plus 1. Okay, I am adding these terms. Okay, so now this value is this much. Okay, so the property is a to the power m into a to the power n, then it is okay. So now this formula became e to the power minus lambda y into this value is lambda to the power n, and this is n minus 1 dy. Okay, now this is a constant term, I can take outside. It would be lambda to the power n into 0 to infinite minus lambda y into, okay, so from here I can take this gamma n to the left hand side. Okay, so in the left hand side there was the value gamma n, so this value is now gamma n by lambda to the power n, which is equal to 0 to infinite. So this is an important transformation of the gamma function where question comes directly, but you have to recognize whether it is a gamma function or not. Okay, so in this transformation questions, in generally in exam they ask that prove this one. Okay, prove this inequality. Okay, and it will come in 8 marks questions. Okay, and if in short question this questions came, then it will come like this. Suppose for 1 mark or 2 mark question, then they will give you the question like this. Suppose minus 2y into y6 dy. Okay, so they will ask like this, find this much. So clearly you know that you have to just compare this function with this function. Okay, So now compare what is the value of lambda. Now see, here it is minus 2y, okay, and here it is minus lambda y. So after comparing, y are common, minus sign is common, so at lambda place there is the value 2. Similarly here compare, this is the power y to the power 6 and here the power is y to the power n minus 1. So here the n minus 1 value is 6. So from here I can tell that the n value is, take this minus 1 to the right hand side, it would be 6 plus 1, that is 7. Okay, so now I got the lambda value, I got the n value, so I will just simply put here. So the right hand side value would be gamma of n is 7 by lambda is 2, so it is 2 to the power 7. So you all know what is the value of gamma 7, it is 6 factorial by 2 to the power 7, and after using the calculator you can find this value. Okay, now we will see another transform. So the next transform states that in this integration substitute x to the power n equal to z. Okay, so here we will get that this x to the power n equal to z, then we will differentiate both sides with respect to x, and we will get this as d by dx of x to the power n, which is dz by dx. Now here we all know this formula, it is nx n minus 1, right hand side is dz by dx. So for that reason I can take this dx to the left hand side, it would be nx n minus 1 into dx, which is dz. So see, there are no n terms here. Okay, so we will have to substitute, so we can take this n to the right hand side, so it would be x to the power n minus 1 into dx, which is dz by n. And why I just took this n value to the right hand side and why not this value? Okay, so here the reason is that, see, while I am doing the substitution, here there is the term x to the power n minus 1 into dx. So for that reason I put this term in one side, x to the power n minus 1 into dx, and took other values to the right hand side. Okay, so now for the limits, what we can do, we will use those values. Okay, so see, when the lower limit is x equal to 0, the upper limit, so z would be x to the power n, that is 0 to the power n, that is 0. And similarly when the upper limit is infinite, I can write this z as infinite to the power n, that is infinite. So limits are from 0 to infinite. So now we will substitute all those values. Okay, so now see, it is gamma of n, which is equal to limits. So now the limits will come for z, right, because we are transforming this from x to z. Okay, so the limits for z is 0 to infinite, here this value is 0 to infinite, then e to the power minus x, right, here there is the x value, so I have to convert this x to the z. So how to convert? Look at this function, this is x to the power n equal to z. Okay, so take this n to the right hand side, so I will get this x as z to the power 1 by n. So here I will write z to the power 1 by n. So into, what is the next term? Here it is x to the power n minus 1 into dx. So we already found this substitution, this x to the power n minus 1 dx is dz by n. Okay, so see, now this 1 by n is a constant, I can take this outside of the integration. Okay, so then what will be this value? It is gamma n equal to 1 by n, 0 to infinite, e to the power minus z to the power 1 by n into dz. Okay, So now let's take this n to the left hand side. So now this n is divided here. So on the left hand it would be producted. So now this value is 0 to infinite e to the power minus z 1 by n into dz. So here comes your second transformation. So it is also a proof basis. Okay, so you will be asked to prove such type of question. Okay, so they will write that prove this inequality and it will come in 8 marks question. Okay, and in short questions also they will ask like suppose find 0 to infinite e to the power minus z to the power 1 by 4. So if you remember this type of transformation, then clearly you will just compare this value with the right hand side. Okay, and see what is written in place of n, and just compare. It is e to the power minus z, here also e to the power minus z, here it is 1 by 4, here it is 1 by n. So this 1 by 4 is 1 by n, that means n is 4. Okay, or just simply see at place of n, here 4 is written, so n value is 4, so the answer will be 4 gamma 4. Okay, so this is for short question purpose. Okay, and in long question also sometimes they ask to prove. Okay, so see this question, here the variable is in x. So as you know that the integration is independent of variable, so it is the same formula as of this, and all the changes are in x. Okay, here the function is in z and here the function is in x. So if you just can compare, then see that at place of x there is z written, and at place of 1 by n there is 2 written, right? So after comparing this one, I am writing just here, just beneath it, so that you can compare. Okay, so see, x in place of x there is z, there is no issue, and in place of 2 there is 1 by n, right? So the 1 by n is equal to 2, then the value of n would be half. Okay, now use the formula to find this one. Okay, so on the left hand side if you apply this formula here, so it would be this value, right? It is n gamma n. So here I got the n value as half, so this value is n into gamma of n, right? So n is half into gamma of half, so we know this gamma of half is root pi. Okay, so but in exam they will ask that prove this one. So how you will prove this one? And just remember that this is the transformation as we have done previously. Just put whatever x value is here, this to the new variable z. Okay, then transform the equation and solve this one. Okay, then another substitution here which is used to transform this integral is, suppose this is the gamma function, then suppose I will take this e to the power minus x as t. Okay, so this is the third type of transformation where I will put this e to the power minus x as t, then what will be dx. So for this let differentiate with respect to x, then this value would be derivative of e to the power minus x, which is, first I will write, then we will see what is the value here. What is the formula for this? Now the formula is minus 1 e to the power minus x. Okay, so what is that formula? Now this formula is, if we want to find derivative of e to the power ax, then it would be a e to the power ax. Okay, so here the a value was -1. Okay, so it is in form of ax, so a is -1, so for that reason derivative is -1 e to the power ax, that is minus x. Okay, so now this value is -1 into e to the power minus x. Take this dx to the left hand side, it is dx equal to dt, and we know this minus sign has no impact, so I will take this to the right hand side. So it is e to the power minus x dx equal to minus dt. Okay, so why I put this term in the left hand side? Now see, here there is the term e to the power minus x dx, it is a combined term, so I can write in place of e to the power minus x dx minus dt, right? So for the next transformation, here it is x to the power n minus 1, so I don't know the value of x, so we will take the value of x from here only. Okay, so before that we'll transform this integral limits. Okay, as we are going to change this from x to t. Okay, so after changing we'll move back. Okay, so first let's take the lower limit of x, which is 0. So when x is 0, we will place the value here, so it would be t equal to e to the power minus 0, that is e to the power 0, which is 1. And when x is infinite, okay, the upper limit, then t would be e to the power minus x, that is minus infinite, so it is e to the power minus infinite, which is 0, which is a standard value. You have to remember this one. So now the t limit is changed from 1 to 0. Okay, and don't change this integral. Okay, the lower limit is 1 and upper limit is 0 here. Okay, because it is accordingly to the x limit. And another term, see here, I don't know the value of x, so it will be also coming from here only. Okay, so what is the equation? The equation is e to the power minus x equal to t. Okay, so now take log both sides. Okay, so we will see this is as log e to the power minus x as log t. Now log and e are inverse functions, so this is minus x equal to log t, and from here this minus sign can go to the right hand side, so x would be log t. Okay, so here this value is exactly not log, you can take the ln. Okay, there is a difference between log and ln. So what is log and ln? So log is function having base 10 and ln has base e. Okay, so I got all the substitutions, so I will write again that function and I will change the limits accordingly. So it is minus x into x to the power n minus 1 dx. So what substitution I got? First thing is the limit of integration. Limit of integration is changed to 1 to 0. Okay, so this is from 1 to 0, and don't interchange this to 0 to 1, as this is accordingly to the x limit. When x is 0, at that time t is 1. Similarly, when x is infinite, at that time t is 0. Okay, so now next, see, this is the term e to the power minus x, and here there is the term dx, and we have already found that e to the power minus x dx is minus dt, so I will write it in the last term. Okay, then x to the power n minus 1. So what is the value of x? I have already found out this one, so x is log t, so this value is log t to the power n minus 1. So as we remember the formula for log, sorry, here the value of x is minus log t. Okay, so if it is minus log t, then I can write this as log t to the power minus 1. Okay, why? Because there is a format. If it is log t to the power n, then it would be log n log t. Okay, so on that basis it happened. Now this x is log t inverse. Okay, so now see, this value is 1 to 0, and log t inverse, it would be log 1 by t, and this value is n minus 1 into minus dt. Okay, into dt. So it is another transformation which is very rarely used, but it may be asked to prove. Okay, so they may ask that prove this identity. Okay, and it may comprise of 8 marks only. Okay, so all those transformations are over here. Okay, and there are some standard values which you may want to find, like the values of, suppose gamma of half is root pi. Okay, and I will give the practice questions for this gamma function at the end of this video. Hope you enjoyed this much, and if you are having any doubts in the practice problems I will give here, then you may use the comment section to ask your doubts. Thanks for watching, and don't forget to like, share and subscribe.